Well, welcome to the second lesson on this one. We're looking at exercise 3 and this one, question 2. And I've just gone ahead slightly and copied out the table because I thought that might make it easier for people. But you should be able to see this yourselves on integral. Question 2 says, in an attempt to increase the yield of a process, the percentage of a certain additive is varied by a technician, while keeping other conditions as constant as possible. So percentage addition and then looking at the yield. And the question says, first of all, calculate the PMCC, the product moment correlation coefficient for this data. So what I've done is I've started to put the data in as I've shown you in the past. So here I've just got to finish this off. 6 in there equals, and the y value of 131.9. So now I've put all the data in there, and the beauty of that, we'll press equals first. The beauty of that is you can check through and make sure it's all done. So I've done that, and then options, and it asks for the PMCC. So put 4 in, and it's got 0.650. Okay, let's do it to 4 sig fig. So the value is 0.6503, and then it asks us, stating your hypothesis clearly, test at the 5% significance level whether there is evidence of a positive correlation. So I've got to say, is there a positive correlation? So first thing I've got to do is say, well, the population variant statistics is rho, so that is rho like that, and that always equals 0. So that always equals 0. And our alternative hypothesis is, let's just say, is it one tail or two? There's a positive correlation. So they're saying that it's greater than 0 at the 5% level of significance. Now, they will give you the value of the critical value on that, or they get tables. Now, in the question here, it says the critical one tail of 5% is 0.6215. The critical two tail of 5% is 0.7067. So they're just testing to see whether you know it. It is one tail, so you know the critical value, because it is one tail, one directional, is going to be 0.6215. And so what you've got to then say is, how far away from the 0 is it? If our value here is closer to 0 than the critical value, then this holds true. If our value is further away from the 0, then you have to say that there is significant or sufficient evidence to suggest a positive correlation. It's all about suggestions. You don't know if it's working or not, but here you can say, since 0.6503 is greater than our critical region, then you would say the same language the whole time, is there is sufficient evidence to suggest, and this is where you have to make sure you put it in context, a positive, because this is what they're asking, correlation between percentage additive and yield. Oops. And is that what they ask you? Right now it says draw a scatter diagram of this data of y against x. So what you now need to do is draw the data against it. And so again, I imagine, like in that previous question, you won't actually have to draw it all out. And what I'm going to do is I'm going to just cheat a bit and show you what the diagram would look like. So here is the yield, and this is the percentage additive, and it goes from about 0 to about 7. So 1, 2, 3, 4, 5, 6, 7%. And the yield goes from there 126 all the way up to about 136. So let's go in stages of 2. There you go. And if you were to plot this, you would see something like this. And I think very soon you realize this is not a straight line. This is not a linear correlation. And that's important actually to understand that just because it's not linear does not mean it's not correlated. Okay? So you have to understand that just because it's not linear, it does not mean there isn't a correlation. In fact, if you see a pattern forming, we are pattern finders, aren't we? You can see that that looks like an inverse quadratic or relationship, something like that, and not a straight line regression. So it says draw a scatter diagram of y against x, and then it says draw a line of regression for this data. Now I have no idea why you want to draw a line through that. It's just ridiculous, isn't it? But they want us to do that. So how am I going to do that? I'm going to use the x bar, y bar values. So I go back to my calculation here and I look at a 2-stage. Oh no, I don't do that. I go to options. It's number 3 and I've got x bar. So I'm using my x bar here of 4.25. If I scroll down, I can see my y bar. Gosh, I need glasses. So y is 132.125. So I now need to put that in here, and it's about there. You should label that x bar, y bar. How are you supposed to draw a line through that? It just seems an utterly ridiculous thing to do. I haven't got a clue. What a stupid question, because I guess, I don't know. As long as it goes through the bar like that, it just seems a really strange question. I mean, who in their right mind thinks this? Now, obviously, you can only draw it, and this is one thing, you can only draw it between the ranges there. So that is one thing that they will hunt for. You can't draw it outside the range. That's called extrapolation. So you're going to draw it in there. Clearly, this is a silly thing. The technician reports that an effective way to increase the yield is to make the percentage as large as possible. Criticize this. Well, no. That's the best yield. It's what you would say is it's not a linear one. It's not this model here would indicate that the best yield is the maximum turning point of this one here. So you could say there is no causation, cause and effect. So it's another thing you have to say, that correlation does not cause causation. It doesn't say there is one. There may be a significant correlation in the range recorded. There may be that, but you can't say one causes the other. And you can't say it's linear either. So his claim is a causational claim, and you can never have that with correlation. So as soon as you see the word causes, you know straight away, you can't make that claim. You don't, you're not likely to drown if you eat ice cream. Okay? So that's that one done.